It has been 2 weeks between Unit 4 and Unit 5. Probably, for most of you. It's been about 15 seconds for me. Let's do homework for Unit 5. So we're going to start with question number 2. The patient recovery time from a particular surgical procedure is normally distributed with mean of 5.4 and standard deviation of 1.9. If this patient recovery time is a random variable, x, we could say x is normally distributed with mean of whatever number I said, 5.4, and standard deviation of 1.9. We could say that. Whoa, my shirt is black. How did that happen? I don't know. Magic shirt. Magic shirts with Jason. That's the next class I'm teaching after statistics. Sign up for that next. Okay. So find the following probabilities. Answer as a percent. All right, follow the instructions and notice the little percent here. Round to 2 decimal places. So what's the probability of spending less than 7 days in recovery? That's the probability that we're doing less than 7 days. We can find that with GeoGebra. It's very helpful for finding probabilities for normal distributions. Well, the mean is 5.4. The standard deviation is 1.9. And you can see this beautiful, all right, now we can see it a little bit. We're curious, what's the probability that it's less than 7? So we sit over here, say, what's the probability? We try to click the right button. There we go. What's the probability that we're less than 7? And we see, oh, okay, look, here's the mean, 5.4. Here's 7. Okay, what's the probability that we're less than 7? That's to the left of 7. It's all of this area. Area is probability for normal distributions and other continuous distributions. This probability is about 80%. So 80.01% is how we'll answer. Oh, the question is over here. 80.01%. What's the probability of spending more than 5 days? Well, that's just going to be the probability that x is at least 5. So right off the bat, right? We know on average it's 5.4. So if it's at least 5, that's going to be a higher than average chance. It's going to be more than 50%, what we think our answer is going to be. At least 5? Well, let's change the sign. At least 5 should look like this. Let's see if it graphically makes sense. At least 5, yep, pretty close to the mean. Bigger than 5 is all to the right. We get about 58.34%. Between 5 days and 7 days, hit this between one. 5 days and 7 days should be 38.35. Graph makes sense. Always make sure that the picture matches with what we think is going on. 38.35. Type our answers in. And nice. We did it. I say we did it, but really, I did it. You guys did not help me do that problem. Oh gosh, I'm weird. Let's look at number 5. The mass of some kind of species of mouse, commonly found in houses, not commonly found in my house. October's on the prowl. Anyway, is normally distributed with a mean of 19.9 and a standard deviation of 0.2. So again, if this mouse mass were some random variable, we could say x is normally distributed with mean 19.9 and standard deviation of 0.2. That's the notation that we use here. Now it wants us to enter it as a decimal place. What's the probability that a randomly chosen mouse has a mass of less than 19.79 grams? So this one and the next one are really similar to the problem I just did. What's the probability that it's less than 19.79 grams? Just do the same thing, but put it as a decimal. What I really want to talk about is C and D. What proportion? No, not C at all. What I really want to talk about is D. 25% of all mice have a mass less than how many grams? 25% of all mice have a mass less than how many, mass less than how many grams? This is the 25th percentile. Remember all the way back to unit 2. I think it was unit 2. Percentiles and cutoff values. 25th percentile is the data value that's above 25% of the data. Okay? So all we need to do is find out what this is. And you can play around with this a little bit. Let's type in everything. 19.9, right? And 0.2. Make sure I typed it in right. Mean and standard deviation looking good. You can play around this a little bit. Right? You go to your graph and say, okay, you know, where do we have to have this so that it's about 25%? And you can get pretty close and get an idea of, okay, it's going to be something around 19.76 grams. But if you want to get an even a better answer, you can just type in 25%. And look at this number here, 19.7651. Once our response is a decimal with 4 decimal places, this is true. 25% of all these mice, assuming it's normally distributed, would have a mass less than this amount of grams. We typed this in and we got it right. We did not get the blank answers right. Apparently, blank was the wrong answer, but this one was right, which is good. All right, let me know if you have questions about any of these. Let's do number 10. Oh, more percentiles, but now with standard normal. Remember that any time in this class, or probably any other statistics class, or anything else really that uses statistics, if you see Z, you should think standard normal. Z is normally distributed with mean 0 and standard deviation 1. Z is standard normal. Z puts the Z in standard normal. That's not the biggest stretch I've ever done. So a Z value of 1 is what percentile? Standard normal. Standard normal. I don't find it anywhere. Well, it's just normal with mean 0, standard deviation of 1. This is what standard normal looks like. Mean 0, standard deviation 1. So a Z value of 1 is what percentile? Well, just replace all the, normally we had X's, now these are Z's. The Z value of 1 is right here. So what percentile is this? Percentile is it's above what percent of the data, so we use this shading over here. We may have to click things around a little bit because GeoGebra sometimes gets a little unhappy. We're going to refresh. All right, click here, click 1. Oh, 84th percentile. Z equals 1 is above 84.13% of the data. Nearest 10th of a percent, 84.1 percentile, right? Yep, there we go. And don't write this, just put the number. Great. Z equals 1 is standard normal. Z value of 1, 1 standard deviation above the mean. 1 standard deviation above the mean is the same thing as saying Z equals 1. That's what that 1 means. Standard deviation, and because it's positive, it's above the mean. 1 standard deviation above the mean. That's the 84th percentile, which means that it's above 84% of the data. Last one for this video, let's do number 18. The heights of adults who identify as men in the United States are normally distributed with a mean of 69.4 inches and some standard deviation. Write that down. X is height, and we know X is normally distributed. with a mean of 69.4 inches, standard deviation of 2.69 inches. What is this? 5 feet is 60 inches, so about 5'9", 5'9.5", about. Okay. Oops, that's not how you write heights. 5 foot, 9.5 inches, about. Okay, and the heights of adults who identify as women are also normally distributed with a mean and different standard deviation. So Y is going to be a height for a randomly selected woman. We know Y is also normally distributed, but Y's mean is 64.8. Standard deviation, 2.54. Smaller standard deviation, smaller average height. This is what we expect. That's about 5'5". Taller than I thought. I thought it was 5'4". And I thought 5'9" was about right. Anyway, doesn't matter. If a person who identifies as a man is 6 feet, 3 inches tall, what's his Z-score? Okay, well, we have to convert it to inches. Okay, if our little x is 6 feet 3, oh, that is tall. How many inches is that? Well, the 6 feet is going to be 72 inches plus another 3 inch. That's going to be 75 inches. Tall person. I went to high school with a bunch of really tall people. This is like a normal high schooler in my high school. Anyway, so what is the Z-score? Well, Z is just going to be this X value minus the mean divided by the standard deviation. X value is 73, 75. The mean for this man is 69.4. The standard deviation is sigma, which is 2.69. Type that into a calculator and we should be good to go. Make sure to use parentheses here. That's going to be important. So 75 minus whatever it was, 69.4. Hey, they got rid of my... Hey, you stop that. 75 minus 69.4, all divided by our standard deviation of 2.69. Make sure I typed it in right. Very important. That's going to be about 2.0818. Z value of 2.0818 means that this man is about 2 standard deviations above the mean in terms of his height. Two decimal places. Oh, it only wanted 2.08. If the person who identifies as a woman is 5 feet 11, also very tall, what's her Z-score? Well, that'll be very similar. Z is going to be X minus mu over sigma. We just have different mu and sigma now. And different X. Really, we're calling the women Y's. Which I guess is backwards. We should have X be women and Y be men, right? Because of the chromosomes. Well, I'm no biologist. Here we go. The Y value is, the woman here is 5'11". So that's 60 inches plus 11, 71 inches. 71 minus the mean of 64.8. I'll lever the standard deviation of 2.54. Type that in. 71 minus 64.8. All divided by 2.54. Make sure I type it in right. Go back and forth. That's a very common error that both me and students make very often. We both do it. 2.44. So almost 2.5 standard deviations above the mean. 2.44. So even though the man is taller, 6'3", the woman is relatively taller. She's more standard deviations above the mean. If she were more standard deviations below the mean, she would be relatively shorter. So in C, who's relatively taller? The woman is here. She's more standard deviations above the mean. Let me know if you have questions about this stuff. Hopefully these videos are helpful. Feedback's always appreciated. And have a good day. I hope that your day is at least one standard deviation above the mean, maybe even 2. Bye.